Today we are going to be talking about normal force. A force is a push or pull resulting from an interaction between two objects. A normal force is a force exerted perpendicular to the surface the object is touching. In order to find a force, we first need to draw a free body diagram. This will help us identify the forces and directions, as well as help us keep track of them. After that, we use force equals mass times acceleration and do a force summation.
The first one we have is a guy pushing a box to the right. So we have an applied force to the right, which is F sub A. We have the force of gravity going straight down, which is F sub G. Then we have the normal force going straight up. The second one we have is a box sitting on a table. Now we have the force of gravity pushing it down, and we have the normal force pushing it up. The third one we have a guy pulling a box by a rope. Whenever ropes are involved, we use a tension force. So the tension force is going to the right.
Then you have the normal force going up and the force of gravity going down. Since this one's at an angle, we're not just going to have straight horizontal or vertical forces. We have the force of gravity acting straight down, but then we also have a static friction force going up to the right parallel to the surface it rests. Friction forces are always parallel to the surface, the same way that normal force is always perpendicular. However, friction goes the opposite direction of intended motion. If there were ice here, it'd slide down to the left. Then we have the normal force going perpendicular from the surface. For the first and third one, there's also a kinetic friction force acting to the left, opposite the direction of motion as well.
A 25 kilogram box is sitting on a table. What's the normal force? First, we have to draw our free body diagram. So we have a 25 kilogram box with the force of gravity going down and the normal force going up. Now, in this problem, it gives us the mass. So we have to do F equals mg, which is force equals mass times the acceleration due to gravity. This is 25 times 9.8. This gives us an answer of 245. Now, since it's the force of gravity and it's going down, it's negative since it's a vector. This means that we need the magnitude and the direction. Now that we know that it's negative 245, we can then do our force summation. We do sigma F sub y equals normal force plus the force of gravity. Sigma F sub y is equal to mass times acceleration.
In this case, it's 25 times 0 equals normal force plus negative 245. Now we just add it to both sides. And we get a normal force of 245 newtons. A box of nails with a mass of 5 kilograms is resting on a roof pitched at 23 degrees. Find the normal force. First, draw the axis to distinguish the 23 degrees. And we have our 5 kilogram box with gravity acting straight down, the normal force acting perpendicular to the surface, and the static friction force acting parallel and opposite to the direction of motion. Now we can find the force of gravity. F sub g equals 5 times 9.8 gives you negative 49 newtons. Remember, it's negative because it's going straight down. Now, because the normal force and the friction force create a 90-degree angle, we're going to use that as our axis. This allows us to only have one vector to break down. In order to break it down, we need to use trigonometry. So we have f sub g equals 49 newtons. Then we have F sub g y, which is our y component. And then we have F sub g x, which is our x component. In order to find these components, we have to use SOHCAHTOA. F sub g x is opposite, F sub g y is adjacent, and F sub g is the hypotenuse. Now we're looking for F sub g y because it's the y component and we're looking for normal force. So we're going to use the CH, which is cosine. So cosine 23 equals adjacent over 49. Multiply both sides by 49. That cancels, and then you get 49 cosine 23 equals 45.104 newtons. Now we could do our force summation. Sigma F sub g equals normal force plus F sub g y. 5 times 0 equals normal force plus negative 45. Add 45 to both sides, and you get a normal force of 45 newtons.